Hello students, today we'll be going with the next problem based on work energy principle. The question says that a 3 kg block rests on 2 kg that is attached to a spring of constant K equals to 40 Newton per meter. The upper block is suddenly removed. Determine maximum height and maximum velocity reached by 2 kg block. Let's consider that this block as block A and this block as block B. Let's see the data what is given, and this is the question which is already mentioned with the figure. So talking about the solution, here the mass of block A is given, that is here 2 kg. Similarly, mass of block B, that is given, which is 3 kg. Okay, let's consider the position 1 as right now. Where are they? Okay, consider this position as in position 1. So the position 1 defines that block B has just been removed. If this is the case, then what is the condition? If I'm talking about a spring force, so spring force, it is M into G. So M into G, basically it will be MA plus MB into G. And as the spring force reacts in opposite direction, so that it has a negative sign. Similarly, this can also be written as minus times of K into x1. If we'll relate these two, then what we'll get is x1 equals to minus times of MA plus MB upon K. As you already know that if you'll equate these two, minus get cancelled, then why this minus sign is coming. Now here this minus sign is just representing the direction, and if you are not representing this, even that can be will do. So x1 equals to minus of MA plus B MB upon K, where into G, where this will become what? MA as in your 3 kg plus 2 kg into 9.81 upon K is 40, which is given here 40, and the negative sign. So the x1 gives you the value as minus times of 122,625 meter. I hope you understood till this position. Now let's consider the second position. So let position 2 be later position. What is the later position? But in that case also you have to see to it that note that spring is attached to block B. It has not left, so it is attached. So we'll see different types of work done. The very first, we'll see work done by spring. As we have already gone with the formulation, so half K x1 square minus x2 square. K represents stiffness of the spring. So here half K is your 40, x1, the x1 is this value, so minus times of 122,625 square of it minus x2 square. So if we'll equate this, then we'll be getting 30.074 minus 20 x2 square. This is my work done by spring force. Similarly, if I'll go with the next one, which is work done by work done by gravity. So if I'm taking a work done by gravity, the body is moving from position 1 to position 2. It will move from bottom to top. So it will be moving from bottom to top. In that case, your mgh will be minus. Why? Because g will be down, h is considered to be positive, as we have done already in the formulation, which is equals to minus m is 2 9.81. What is in h? Now here you have to be very careful. Right now, as the spring is already deformed, so deformed spring is having a value which is x1, what we have determined. As 3 will be released, it will reach to some distance, which will be again having a deformation, which is x2. And if I'll take x2 minus x1, then I'll be getting the exact height, that what height it has reached along with 2 kg. So here I'll be writing x2 minus x1. Now here minus 2 times of 9.81, x2 I don't know, x1 I know as in minus of 122,625. Okay, if I'll solve this completely, I'll be getting an equation minus 19.62 x2 minus 24.059. This is the work done by gravity. Now if I'll add both the work done, which is your a plus b, then in that case what I'll be getting, this value, which is 30.074 minus 20x2 square, and then this term, which is minus 19.62x2 minus 24.059. If we'll equate this, I'll be getting 6.015 minus 20x2 square minus 19.62x2. This will be the work done. Now we'll go with the kinetic energy. So if I'll consider the kinetic energy at the position 1, so if you'll see that at the position 1, the block was resting and it has been released, suddenly removed, so it is resting. So in that case, kinetic energy will be 0. Why? Because velocity at this point will be 0. Similarly, we'll go with the kinetic energy at position 2, that is half m v2 square. So in that case, half into m is 2 into v2 square. So if I'll relate this equation, which is, let's take equation 1 and this as equation 2. So work done is equals to, there is a change in kinetic energy. So from these two equations, we'll just plot it here and then check that what is the condition happening. So 6.015 minus 20 x2 square minus 19.62 x2 equals to, kinetic energy is your half into 2 into v2 square, and ke1 is 0. If we'll equate these two, here 2 got cancelled, here v2 square you'll be getting in the terms of x2, and that x2 will be your 6.015 minus 20 x2 square minus 19 x2. This is the equation what we'll be getting in the terms of x2 for v2. Now the question says here that we need a maximum velocity. So if I want to go with the maximum velocity as well as the maximum height, so in that case, if I'll write derivative dv2 by dx2 equals to 0 is the maximum condition. So this above equation, I'll just write it here for maximum. If this above equation will be related with this, then what it will be giving you as 2 times of v2 dv2 by dx2 equals to this constant term, so 0 minus of 20 into 2, 40x2 minus 19.62 only. Now as you already say that dv2 by dx2 is 0, so this will, the whole term will become 0, means 0 equals to 0 minus 40 x2 minus 19.62. If you'll relate this with this, you'll get x2 is equals to minus times of 0.4905 meter. I hope with this we determine the x1 as well as the x2. Now the x2 what we are getting is the maximum point at which the block along with the spring it will reach. Now this vx2 value, if I'll substitute it here, then what I'll be getting, I'll just divide this page into the part, and if I'll substitute this x2 in this equation, then what I'll be getting is v2 square equals to 6.015 minus 20, x2 here it is this, so minus 0.4905 this square, as it is a square, minus 19.62, 0.4905. If we'll relate this whole and find out the value, then that will give me v2 is equals to 3.29 meter per second, which is my maximum speed. Now I have to find out what is the maximum height. This is not the maximum height what we are talking about, it is the reachability distance for the spring along with 2. We need that maximum height it is reaching from the deformation point. So if I'll see for maximum height, my velocity should be 0. This is the condition what I was explaining you, that unless and until my velocity is not becoming 0, the maximum height I'll not be able to reach. So if velocity is 0, means this equation, or we can say as in this equation, if I'll substitute velocity as in 0, whatever I'll be getting in x2 can be considered in one term as in a maximum height. So let's see. So substituting this v2 in this equation, 0 equals to 6.015 minus 20x2 minus 19x2. This is square and this is the normal term. This becomes a quadratic equation. With that, I'll be getting an x2 in two forms. One is your minus 1.226, or the next one is 0.2453. These are the two values what I'm getting here. I'll take a positive value, which is x2 is equals to 0.2453 meter. Now I need to find out the maximum height, that is your h equals to x2 minus x1. So my x2 is 0.2453 minus my x1. When you reach to x1, where is an x1? So when you see my x1, which is your minus 1.22625 minus 1.22625, if I'll equate these two, I'll be getting h equals to 1.47 meter. With this, I hope you understood the whole solution of a problem. Thank you.